Okay. So, who am I? I'm an electronics engineer. I'm not a tester. Who's a tester? Who's not a tester? Who's a developer? Okay. And the others? Nothing. Okay. Oops. It's dangerous here. Who is a QA person? It's not the same as testing, is it? Okay. I talk about quality on time, the right stuff at the right time. And Capers-Jones, he measures everything in software. Yeah. He said the most effective way of improving software productivity is shortening project schedules. To do that is to reduce defect levels. Do you guys count number of defects? Who counts the number of defects? Who doesn't count the number of defects? You're fooling me. Who is counting the number of defects? Who is not? Oh, you're still fooling me, but anyway. Never ever count number of defects, because it sends a message to the developers that they have to produce them. Otherwise you can't count them. So, quality and on time is improved if we work towards reducing the defects, right? So, why are testers so obsessed to find the defects? We shouldn't have them, should we? Anybody knows the W model? Or the waterfall model? You know, the first people who made this picture, he said it doesn't work. V model. Yeah. Now the testers added the extra V to make it a W. And of course it's a waterfall folded. That doesn't mean it's wrong. Because anybody doing agile? Small, short sprints? Okay, a sprint in a waterfall, isn't it? First think, then do, and then be happy. So, it's only shorter. So, can you test if there is no code? Yes. Of course, because you can test the requirements. You can't run the requirements, but you can check them before they pollute the next level. You can test the design and the specification. And then you have working code, and then you can test that. But there are many ways of testing before the code is polluted with all the wrong things in the beginning, which are much more expensive. Now, we are people, aren't we? And people make mistakes. Do we? Once we know that, we know when we do something, we are making mistakes. Developers inject defects, and testers don't test the right things. People make mistakes, we are people, so if we do something, we are making mistakes. Okay. Repair of problems costs exponentially more if found later. If they're not there, it's cheapest. Caught immediately after injection is less costly, and caught later is very costly. Right? So, when do we solve the problems? Immediately after injection of the defects. Or, preferably, by prevention. Not even having them. Because prevention costs much less than first inject, and then hopefully find, and then hopefully repair. What's all these wires here? Anyway, so, and the simple equation is, first injecting the defects, then trying to find them, and then doing it right is 3 times more expensive than doing it right. Simple? So you have a huge budget to do it right. So, anybody knows the name of Dijkstra? He called himself the first programmer of the Netherlands. And he says it's a usual technique to make a program and then to test it. Program testing can be a very effective way to show the presence of defects, but it's highly inadequate to show their absence. So what are the testers doing? Going after the defect? What should we be doing? The developers should make sure that they don't produce them, and the testers have to show that they are not there. And testing is highly inadequate to do that. Is that the dilemma? So, I want to give you some ideas how we can do better before we test the working software. And therefore, we have the technique of reviews and inspections. Who does reviews? Who does inspections? It's a special type of review. Okay. Nobody, most of you not doing reviews? The people who do reviews, have you been educated in reviews? How to do reviews? Because without education, review is almost ineffective. And the people educated, no. Yeah, you find 100 times more. Yeah. Okay. Now, we can do a lot before we have code that doesn't work. How do we prevent? First, by designing. And I have the concept of the design log. We log our design process. At the top of a chapter, we say what we want to achieve. At the bottom, we say, this is how we think we're going to achieve it because, and that's in between. The reasoning. Yesterday, I was at the company in Minsk, and I didn't even have to ask. They said, this is how we work. First, we design. We check 3 possible designs, and we reason why we choose the one we choose. So this was used. I taught this in a company in Dublin, and the guy who asked me to come to Dublin now was in another company in Dublin, and he said, can you come to help us to define better requirements? Because I had this development team, and I asked them, what's the goal of your work? And they didn't know. They couldn't tell me. So I said, come over and let's talk about how to define requirements properly. So we did that. In the evening, they had their monthly pub day. Thursday, every month, one time, they went to the pub, had drinks and things, and discussed things. So they said, come along to the pub. And in the pub, James came to me. James was the guy who invited me. And James said, Niels, here's Louise. Louise, tell your story. He taught me design logging. Tell what you did with that idea. So Louise said, and James left. And Louise said, well, we had 7 days to deliver stuff. So what do we do? Coding, testing, coding, testing, coding, testing. You recognize that? Okay. And then she said, James came in. So that's what they were doing. Yeah, that's what they were doing. I found this picture on the internet from a company who produces stuff to do this very quickly. Well, I think, oh, that's the wrong button. I think that's very bad. So James told her, stop coding and go back to your design. What design? Go back to your design. Yeah, but we don't have time. We have only a few days. We have to code and test, code and test. He said, go back to your design. And apparently he came into that company at a level that you could say, you go back to your design and you stop coding. So she did. We designed, which means you just picture it on the whiteboard or on paper or wherever, and you reason how things should work. We found the problem, repaired it, cleaned up the mess we introduced by all the coding and testing, all the scars and the band-aids. And we were done in less than 7 days. Thank you. So I put this on my website as a page, and I sent them an email to James. I said, James, this is what I think she told me. Can you check with her? Well, James said, well, actually it was much more interesting. Because once she did her design, I gave the design to somebody else to review. And when she found out they were going to review this, she said, oh, if they're going to review, I have to do it much better. He said, no, you did your best, and let's see how it worked out. So there was some review, somebody found some issues, she reworked it, and then he said, let's do a final review. Now in the final review, another guy came in, and based on his knowledge, they completely changed the design. He said, the way you designed it, it won't work. And he explained why, and then together they discussed how to do it properly. So she did that, and it simply worked. But then he said it was even more interesting, because her team had to do 2 features. And one they did this way, and the other one they did on the other way, the old way. Guess what happened? The design way simply worked, and the other one was full of bugs. So since then, he said, we're using design logging. First you design, and then you review, and only if you're happy, you code, and then you review the code, and only if you're happy, you test, and the test doesn't find anything. Every time again. So don't worry that you lose your job, but maybe your job must move. The better you help the developers to become, the more your job moves in helping them become even better. So, if there is still an issue in test, don't debug, don't put a band-aid there, go back to the design. Yeah, but it takes more time. No, it takes less time. But if you ask developers, where's your design? What's the answer? We don't have any. Because if you look over the shoulder of a developer, what do you see on the screen? Only code. Yeah? Now, if you work only in code, of course you are bound to make bugs. And if you first design and then let the secretary do the coding, then there are no bugs. So, I suggest you, if there are bugs, you go to the developers and you ask, where's the design? Can we look over the design together? It's even so that if I ask somebody, can I review your software? They send me code. I say, of course I can look at your code. I could even review it, but what's the point? Because the moment we reconstruct the design and we go in that process, after that the code will change so much that it's no use in looking at your code first. Can you imagine this? So we check what's wrong with the design. If there is none, we reconstruct the design. And every time I do that with people, just on the whiteboard, within half an hour, they find the causes of problems they have been working on for years. Every time again. Half an hour to find it, 1 week to solve it, and then some people think I'm expensive. And I wasted years not finding it. Yeah? So, some people use the word QA and mean testing. I don't mind to say testing and meaning QA. So what's QA? Testing is the measurement, and QA is helping the developers to do a better job. So how about helping the developers to do a better job? Being a consultant for development? Other case. It was also James, but in his previous company. And he asked, now you taught us a lot, but now can you teach us inspections? I said, okay. But I thought they are not really up to a good quality level, so I did a very short introduction. And then I said, let's just make a baseline, because of course everybody's reviewing in that company. So you review? Yes, we do review. I said, let's take some document, take 1 page out of it, you copy it 20 times, and you review, just to see what happens. So it was some design document, 1 page out of it, and after 5 minutes people started looking around and, you know, okay, you found something? Maybe a typo or so. So, then, that's what we did. No issues. Thank you. So, I introduced one rule. In inspections, we use rules. The rules are the laws of the document. It could be the rules of coding, it could be the rules of writing requirements, it could be the rules of whatever. And you should obey the law. If there is no law against it, you can do anything. Yeah? So we have rules. And a defect, an issue, is a violation of a rule. So I introduced one rule. I said, how can you determine that this design document, which tells how we are going to implement something, how do you know that what you're going to make the computer do is what the computer should do, and that you also make sure that the computer does not do what it should not do? How do you know? Do you know what it's supposed to do? It wasn't in the design document. So I said, now you review again. And immediately, this I can't judge, this I don't know why, this and this and this. So, they learned that with even one rule, they already find a lot of potential issues. And this gave the author of the document, a senior firmware developer, the idea, maybe I have to write down why I'm doing this, my reasoning, so that we understand why this is the right solution. So James said, from now on, first you do your design log, then review until happy, and you are not allowed to write any line or change any line of code until we are happy. Okay? So I went home. And every week I sent an email to the guy, how is it going? Well, he changed his document name to design log. That was ready, some acceptance. But then after a few weeks, I asked, how is it going? Oh, it's not going. Niels, you're delaying my project because I can't code. So, let's see what it was. They do building automation. They have many units in the building doing air conditioning, lighting, etc. Lighting, not lightning. Yeah. And they have some routers and they connect to the internet. So the head office of a supermarket chain can check the climate and the lighting and energy consumption of all the subsidiaries in the whole country or in the world. And so they do also data logging. So these units log some data, and from time to time it's sucked up by a server. So there was somebody talked about glitches. There were some glitches. They lost some data. So, and they were going to do that in the firmware, to update the firmware so that there were no glitches. So, he wrote down, I'm going to do it this and this and this way. Okay, I hope it has a battery. So he wanted to solve the glitches. So, but he waited and waited. Design log is a nice concept, but he didn't really understand. So one weekend I sat down at home and I thought I knew about this problem and I started writing. I said, this is the problem and this is my reasoning and therefore blah, 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 blah. I made 3 pages, I sent it to him, and a week later he came back with his design log. So apparently he needed an example. So, you know what the conclusion was of this design log? I'm not going to implement it. Because I talked with our software guy, and instead of implementing it here in firmware, it's much easier to do it in software. So, imagine what would have happened if he would have started coding already. Going deeper and deeper in this swamp. He decided, I'm not going to do it. And he was nice enough to tell me, Niels, thank you, you saved my project. And so, no code until design log is reviewed. You're delaying my project, gave him an example, he made the solution, thanks, you saved my project. Yeah. And because we have the design log, we can review, and you testers, you look differently at the stuff as they do, so you see things that they don't see. Yeah. And what did I use here? Using inspections in different ways, in various ways. I give this example because I didn't teach inspection to teach them inspections. I had to show them that the way of making design was not right yet. Now, if I tell you, your design sucks, yeah, you don't like that. I mean, you know it is so, but even if you know, you don't like to hear that, so you get resistance, even if people agree. So I used inspection to let them tell themselves that the design sucked. And then they were ready for help. So you can use inspections to let them tell themselves where a problem is. Think about it. This, I recently dug up his design log. It was 8 years ago. This, I could just copy-paste it. Yeah? And see how he wrote it down nicely. A number of firmware-based methods of removing the glitches from the data log reading process have been investigated. But it has been decided to go with a mechanism implemented in the external system reading the data log to remove the glitches. Isn't that a nice way to say it? Yeah. Other case, City of Amsterdam, they had some project. And they had some tender document. A tender document you send to potential suppliers. Yeah? But maybe they felt some uneasiness about it. So they called me, Niels, can you teach us inspections? And we have a document to learn. Okay, I said, of course I can do that, but I have to warn you. You will ditch the document after the day. You will throw it away. Because that always happens in the first inspection education. Yeah? That was the answer, ha ha ha. Well, you can imagine what happened. They ditched it. They thought this was just crap. So in inspection training, you learn to see the crap, and that's the start of learning how to do it better. Most documents are crap because nobody is educated in how to write a document properly. And inspections are a technique to help us, not help you, no, help us to learn to write proper documents. As short as possible, but not shorter. So, another way to doing it, because inspections can be very costly. Yeah, if you have so many pages, and you must spend so much time per page, otherwise you don't find anything. 10 minutes, you find nothing on a page, and after 20 minutes, you find a lot. So at least 20 minutes per page. If you have so many pages, you don't have enough time. So we don't do that. Now, we know if people make any document, they're introducing defects. Now, why would we wait for the whole waterfall of injecting all the defects in this document, where we know he's injecting? Why not let him inject a few defects, inspect very quickly, feedback within an hour. These are the tendencies of injecting defects we observed in your work. Can you repair them and prevent them in the rest? How about that? Prevention. So, Erik Simmons, a friend of mine who used to work at Intel, Intel just last month released all agile people from duty. Okay, I think the money people are running the company now, but that's another story. So he told me how they used to do it. Early inspections. So give me a few things. Let me show you some tendencies. Two people, me being experienced in doing inspections, knowing what to look for, and one content, somebody knows about the contents. We feed back within an hour, because we are trained to do that very quickly. And then some authors can ask intermediate, do I already prevent enough? And at the end, you do a formal inspection. So I have here two cases. This case is in the handout. You can download. The other case I just added yesterday because I thought I used the wrong one. And there's also about test cases. So I add that one. So one example he used is requirements writing. Now, why there are so many requirements, why so many people writing these requirements, that's another story. But there were 8 requirements authors. Each sent the first 8 to 10 requirements of about 100 per author, so they were supposed to write some 800 requirements. Is this agile? That's another story. The initial reviews within a few hours of submission, they used it. Some had some more inspections, and then let's see what happened. At the first inspection, thank you. The first inspection, about 8 major defects per requirement. And after that, 3. Now, in inspection education, we learn how to calculate the benefit of inspections. Otherwise, management thinks it's too costly. So we calculate the benefit. So the time investment for this process, 26 hours. 12 hours in initial review, 1.5 per author, times 8, 12 hours. About 8 hours in additional reviews, some authors ask more. 6 hours in the final inspection, 2 hours inspection, 2 checkers, plus preparation and finishing. Major defects prevented, 5 per requirement, which means about 750 major defects prevented. And then we do a calculation. Five times 750 times 10 hours. The definition of what we call a major defect is 10 hours extra work later. Yeah, times 10 hours is so many hours. But not every problem in the requirements ends up as a defect later, because developers are not that stupid. Yeah? So we divide it by 3, that's a statistical thing by experience. It's so much times, let's say $50 an hour, whatever. Yeah? We saved $500,000. How about that? Now that's the requirements, but it's not only for developers. Even testers can use this. Not just on development stuff, but on your own stuff. So, test cases. Somebody was writing test plans. Yeah. Early inspection used on an existing project to improve the test. So they already had the whole test plan with all the test cases, but they used the technique taking a sample. We found 6 randomly selected test cases. And we inspected them. And this is what happened. Let's go to the result. In the first round, they found 6 major defects per test case. Now, there's a whole story. In inspection education, you learn how many defects there are usually in documents. It's about 1 per word. You can't imagine it until you learn how to do that. Yeah? In the second round, 0.5 major defects per test case. So, they checked 6 random test cases, they found 6 major defects, and he used that information to go through all the test cases to repair wherever necessary. They did another review and found 0.5 defects in the next sample, just taking 6 others. Time investment, 2 hours initial review, 36 hours total in final formal inspection, excluding rework. Historically, about 25% of the defects found by testing were closed as function as designed. You know what that means, I suppose, as testers? Yeah? You think it's wrong, and after investigation, which takes time, we decide it's still right. Normally, their statistic was 25% ends up as it works as designed. Whether it's proper, that's another story. But it took about 2 or 3, 4 hours to find that out. Test plan had about 1,100 software defects, with only one defect closed as functions defined. So the improvement on this was from 25% to just one defect. Time saved 500 to 1,000 hours, 25% of times 1,100 times about 3 hours. Yeah, you're saving time. Defect prevention in action. Yeah. Then, that's an interesting one, he said. First inspection of the tester's next test plan, 0.2 major defects. So he processed it in his mind for making the next test plan, making even less. So he learned how to write proper tests. Inspection is about learning to do things better. So, do I have still a minute?
20 seconds.
Okay, then 20 seconds. Well, you can read this in my handout. I knew, because I added the test part, that I knew I wouldn't have time for this. So I don't mind. Any questions?
Now it's questions time. Who first?
Or is this so remote from your testing activities?
No questions?
Then I can finish.
It was a good presentation.
It was too good or not good enough.
Oh.
First of all, thanks for your presentation. It was useful for me. So I get a question about the requirements. You said we need to have a short requirements, not the huge lists. So many you can tell about something methods how to make the requirements shorter.
You can come to London next week, 5 and 6 December. I have a workshop on that. It's almost free. Only you have to pay your travel, etc. Okay, how do you do that? But the real requirements, there are only a few real requirements on any project. And they basically never change. Why do you do some software development? To support people to do something better that they were already doing. Right? The functional requirement is just scoping the project. We are going to improve these things people already do and not these things people already do. So the functional requirements we always see in the requirements document. And do you see the performance requirements? How much better people are going to do it with your software? Do you see them? Yeah? So our software is going to make sure that the people first spend half a day on something they have to do in the business, and with the software it takes only 10 minutes. And they have 3.5 hours extra to do other stuff or go on holiday. That's what we do in development. That's all. Improving something. So the performances are the essence. So, business case, this is what they do. They now spend so much, and we want them to spend so much. You do whatever you want. These requirements never change. Maybe the numbers change, but the requirements doesn't change. It takes only one page. And we have a technique how to do that so that even the CEO understands what you're talking about. Very concise, very clear, numeric, etc. So, anybody having this booklet, I had the project in Manchester, and they had this booklet of 4,000 requirements. Yeah. And I said, shouldn't we ask the customer whether he's happy? So I went to the customer, and the customer told me privately, he said, Niels, we are not going to use this software. So I talked to the project manager. I said, I just heard from your customer, they are not going to use it. What will you do? She said, well, they signed with blood the 4,000 requirements, we deliver, and they pay. And then I said, if in that case, I don't have to come anymore, so I left. What's the point in paying me money for doing whatever you like and not listening to me? You don't have to listen to me, but then don't waste your company's money on me. Yeah, it's a little bit an answer. So, of course, these bunches of requirements, yeah, but they happen. Anybody sees these big requirements documents? Never? Then we can talk about user stories. They are even worse, but anyway, that's another story.
Any questions?
First of all, thank you for your presentation. My name is Yulia, and I have a question. How can we, just regular QA people or developers, explain the management, the business part of the company, that we need to spend some time on inspecting and reviewing instead of coding and testing? So that's my question.
Okay. Don't tell them. Just do it. Yeah? The only problem is, if you do this, you will done more quickly. No firefighting. So you don't get promoted. So the only reason why you do this, that you want to do a better job. Management only comes down if things go wrong. So if you want to get promoted, you must make sure that everything goes wrong and do your best to make the best of it, and then you're a hero and you get promoted. I call that the Homo power effect. That's maybe before you were born, but some decades ago, Unilever had a project where they had Homo power, even whiter laundry. Yeah? And then all the laundry got holes in it because it destroyed the laundry. Yeah? And Procter & Gamble, they knew that. They kept you know, the manager who led this project, he became member of the board of directors. I call it the Homo power. If you make problems, you get promoted. If you do a good job, you don't get promoted. So it's your choice. Do you want to go do a good job or get promoted and feeling I did a bad job? That's up to you.
One more? We have time for last question. Okay, what should we do if, for example, I go to a new team and I would like to do this, and how can I explain that it's useful for team?
It's not easy, I know. So you know what, you saw what I did. But it was not so difficult for me because he asked me, can you help us inspections? Because James knew. Yeah? And he probably also had trouble to explain to them, so use an outsider. Yeah? An outsider can say something. If I come, I say something, should we do it this way? And then suddenly it happens. And then you say, I said it already for a year, and now you say it and it happens. I said, well, that's the function of the outsider. Yeah? They listened to somebody else, they heard you, but they were so busy. Now the outsider comes and maybe they try it. So that's one of the tricks. Yeah? And, well, also, one of the other tricks of doing it, if there is no pain, there is no gain. Yeah? No pain, no gain. If they think everything is okay, they're not interested in anything. So either wait until they hit the tree or make them hit the tree. And then then you can say, okay, now this happened. Now I've heard about something, let's try it. Not, you have to do it. No, let's try it together, let's find out. Yeah? Words are important. It is never, you did something wrong, and it's difficult to remember, but try it. Never say you did it wrong. We did it wrong because we didn't help you to avoid it. Very important. Never use you, always use we. Yeah, many little tricks I use to let them do things that before they didn't want to do. But it can be difficult, I know.
Okay, thank you, and let's applause for our... And don't forget about feedbacks, please. We need your likes.